Welcome. My name is Erik de Baat. I'm the sales manager of MicaSense and part of AgEagle company, of course. So for those who don't know our company, let me give a very short introduction, and then we get directly to all the questions. So where you can get the questions is in a webinar below. There is a part that you can write down your questions. So ask me anything about cameras, prices, technical integration with drones, usage you can give for certain kind of crops you're thinking to work with, anything, right? So Annaluz, she will pass on the questions to me, and then I will randomly pick them and go directly to the answers. After the webinar is done, 24 hours later, you will get a repetition of this webinar, so you can have a review the questions and everything that we have been talking about during this time here. So approximately, we expect we're going to give very short explanation, like 15 minutes of the company and the basic usages of our cameras, and all the rest is just to answer your questions. So once again, welcome to the webinar, and let's go. So AgEagle, that's the mother company of MicaSense, already since many years. Besides the cameras, we make also the SenseFly drones and some software as well, both for flight planning, ground control station, and but we do not make stitching software, right? So the MicaSense cameras are still quite drone agnostic and software agnostic. That means that our cameras can fit on any drone, large enough to lift up the weight of the cameras, and the most photogrammetry suites that can process drone imagery to make maps can also work with MicaSense cameras. Probably, I'm not sure if all can also work with the dual camera, but the RedEdge-P and Altum-PT data are definitely very well served by all known drone platforms. We can talk about these more specifically later on during this webinar. So how it works. First of all, we need to capture, right? There are many questions on how should I fly to get optimal results, right? So we can process them quickly and analyze the data. So first of all, about capturing of the data, what's needed to know here is that the camera has an automatic shutter, right? So that means that the capture time is determined on what's below. So for example, if you fly over a very dark object like a water body, the shutter time will be longer, right? And if you fly over like a white car, the shutter time will be a lot shorter. So that means that if you make a mosaic, the images might have different shutter times and illumination. So the reason why we ask everybody to fly with 70% overlap, which is a lot, especially if you don't want 3D data, because for agriculture, usually it's okay with a 2D map. It's because we want people to be able, at every point is like in at least 15 different images, every pixel, and we can make a mean value so that all these optimizational differences for the images are leveled out, right? The alternative would be to have a fixed shutter time, right? But then if you want to work like this, you need to know what's the optimal shutter time for the illumination at that moment in time, right? We can explain this later on in the configuration of the camera, how you can set this. Also important is to fly always on the outside of the limits of your terrain. So if you mark your terrain, you need to fly really around it as well, so that the inside pixels are also covered from all sides, okay? All right, then the processing, of course, we need to overlap. It's with the point cloud. There are different ways to process. We can also make 2D maps. And then we can go to the analytics part that can be done in QGIS, directly in a software like Pix4D Fields, or since we are adding more and more spectral bands, remote sensing software is also becoming more and more important to process and analyze our imagery. I'm talking about software like RDAS, MV, that kind of software. So let's go to the first questions, right? So the first question here is, what's the purpose of the blue channel and what type of indices is it used for, right? So this is a very interesting question, actually, because we have two blue channels, right? Because we have, as you can see here, okay, these are the cameras we have. So for the RedEdge-P Dual, we have an alternative blue band, while on the RedEdge and the Altum-PT, the blue channel we have is at 470 nanometers. There is no, the blue band is not used very much for indices, right? Why is that? Because this technology, the remote sensing technology, is actually born in space, right? The satellites were the ones in charge, first of all, to make vegetation indices. And the blue band was always left out because there is too much noise in the sky. It's called ray light scattering. That's because the blue wavelength is so short, so the probability it collides with hydrogen and other elements in the atmosphere is quite high, so it scatters. That's the reason the sky is blue, right? So the information you can get from the blue channel always contains a lot of noise. But if we work with drone imagery and we fly at 100 meters above the ground, and there is not that much noise between the plant and the sensor, right? So that's interesting. However, it's interesting because we can start using it more and more, but there is not that many indexes that people use it for. Practically, where people are using it most for is to make an RGB image, right? Many people ask also, Eric, we use as much RGB images as multispectral images when we analyze an agricultural field. Why don't you add just a high resolution RGB camera to it? So the reason that we have this blue channel is that you can make your own RGB composite with the blue, the green, and the red band, and make it high resolution with the panchromatic band we have included as well. So that's the main reason, actually, because visual interpretation of an image is still important, right? So we really need the RGB images also for multispectral analysis, although not that much for analysis, but more for the visual interpretation of the area. Then we go on the coastal blue, which is an even shorter blue band we have in the RedEdge-P blue version, right? And that's coastal blue, as we call it. And the reason that we added this band is because we discovered that this band is really interesting for the study of the clearness of water, right? Because our cameras are not only used for agriculture, they are also widely used for any remote sensing application, especially for environmental applications. And one of the applications, of course, is the water quality studies, right? And how turbulent water is. There are many examples, many practical examples of studies that require this kind of information. And the coastal blue band gives different responses on the clearness of the water. Really interesting. So thanks for the question. All right. Next question. How do you implement pansharpening on the RedEdge-P? Any recommendations or procedures? All right, that's an interesting one. Well, I can mention here two different things, right? First of all, I can mention you the origin and why we do it like this to give you a very complete answer. And then I will give you the specific software and the options you need to do to get the pansharpening done. Okay, coming back to the answer before that, why don't you get a high resolution RGB camera, and why do it like in a complicated way with the 5 multispectral bands and a high resolution panchromatic band, which is just a black and white camera, right? So and use that to enhance the resolution of the multispectral images. The reason why we do that is because there is no other way to capture high resolution data at such a velocity as we're doing now, with like 3 images per second. So the way to enhance the capture rate, it's an offset, right? Or we take the pictures at a slower rate and all the bands are high resolution, or we speed up the capture rate, but we do the high resolution artificially after the capture, right? So we have the low resolution multispectral band and only one high resolution. That's in terms of megabytes, a lot less than 5 high resolution. So we can have a higher capture rate. It is important because especially the field trials, they need high resolution and they fly very low. And if you want to maintain more or less a good speed of your drone, it needs a very fast capture rate. And we are already on the limit. If we are using this compact flash card, which is like the extractable card, fastest on the market. The alternative would be like have an internal hard drive, and we do not have that if we want to go even faster, right? So how do we do that practically? That's something you do in either Pix4D fields, where you have an option that you can tilt, make pan sharpening once your orthomosaic is done. It's just one tilt that you need to click on. So that's the easy one in Pix4D fields. Then we got Metashape or Agisoft, however you want to call it, where you also have this option, but usually what you want to do is join them after, right? And even not do the pan sharpening, depending on what you really need it for. If you want to do spectral analysis of the images, what I personally recommend you is to use the multispectral images without the pan sharpening, because the reflectance values may deviate like up till 5% after pan sharpening, right? Because you're going to mix it up with a grayscale image. So how would I recommend you to use all the data of the camera to take advantage from the high resolution of the pan camera and the spectral information of the multispectral camera is because they are co-referential, of course. So you can use the not the pan sharpening, the panchromatic band for segmenting your image, for example, or to find the borders of the objects, and then colorize that information with the multispectral data. So you can write me a private message if you want to have more explanation in detail on how to work with this kind of information. Let's go to the next question. Greg, is the RTK position image tagging available for the RedEdge-P dual mounted on a DJI drone? Oh boy, you really hit us hard here, because yes, it should. And we are having some support tickets that we are getting some problems with it, right? So we are actually right this week working on it. So what's going on? We do have a Skyport version for the dual camera. For those who don't know, we have 2 ways to mount our cameras on DJI drones, right? We have a device called a quick mount and a device called a Skyport. It's exactly the same thing. The difference is the Skyport has integration with the autopilot of DJI, while the quick mount is only receiving the power. Skyport, the biggest advantage that you can get from it is because it takes in the RTK data from the drone. So from a TRIS 300 and 350, it is tested and it works. For RedEdge-P, it works. For Altum-PT, it works. But for the dual camera, we only implemented this not so long ago, and we had some people that had some problems with it. Maybe it was a difference in the firmware, we are testing it this week, so it should be solved in any time soon, if that's the reason why you're asking for. Yes, we have it, and it should work. I can imagine there are also many questions about if our cameras are already compatible with the Matrice 400. So it came out like 3 weeks ago. I'm very excited. I love the drone. It looks awesome. We need to test 2 things here, right? The SDK of the Skyport should be compatible. It's the same version, so we need to test it. We're also going to test it this week. We couldn't get our hands on a Matrice 400 earlier. And we need to find a solution for the DLS2 that needs to come on top of the drone, right? Because now on this one you have a LiDAR, and we need to see how the DLS and the LiDAR can work together without damaging each other. Okay, so next question. We are interested in our department in acquiring one of your cameras, MicaSense RedEdge-P, for biodiversity studies and plant functionality studies. Do you recommend this model or another MicaSense one? Okay, I love it. I'm a biologist myself, so I try to find whatever we can do with the multispectral cameras all the time. And I would recommend you here the dual camera, right? Because what you want is more spectral information. I can imagine what you want to do is determine plant species. And if you, as you might know, every plant species has its own spectral signature, right? It's like you can tell what plant it is just because how it reflects on each of the multispectral bands. So 5, the RedEdge-P, it's optimized for what you can do in production agriculture, right? But for biodiversity studies that you don't really know for which plant species you want to look at, for a classification of an area, for example, and a follow-up of biodiversity, what you want is more spectral information. So what I definitely would recommend you here is a dual camera, and work with them for species classification and habitat mapping. All right. Let me see. Okay, right. Gustavo, can the frequency of the bands be changed? That's also a very interesting question here. No, but that's the right answer here. So our bands for the RedEdge-P and the Altum-PT, they are fixed. They're done. We cannot change it. We had a lot of questions of alternative bands and indices. People wanted it. So that's why we brought to the market the RedEdge Blue, right? But we're getting more and more questions about alternative bands because, of course, now we also have hyperspectral cameras on the market, quite some good ones. Most of them are a little bit expensive or with not such a high resolution. But what we can definitely add, well, what we plan to do, and pay attention to our news channels, we are definitely going down the path of adding more multispectral bands, right? Not by customized camera, but by adding more products that allow us to visualize more spectral information, right? Very exciting. Thanks for the question. Okay, I think here we got to the pricing part, right? Our cameras are not cheap. Right? They are not cheap. There is a reason for it, of course. And if you want to buy our cameras, probably in Europe, it's the good moment because the dollar is so low. And if you want to know what kind of dollar, it's the American dollar, not the Canadian dollar or the Australian dollar. If you're, because I got here a question of what the prices of the cameras are, if it's US or Canadian dollars. It's an interesting question. It's funny, but if you are, if we have public here in Canada, I can definitely recommend you to talk to our Canadian reseller, which is Measure. They're very, very good people that can help you out on all the information you need. And on their website, the prices are on Canadian dollars. That's for sure. So yeah, our products are in American dollars. The cameras are made in the US. It's fully US-made product. So if you want to know about price changes due to tariffs and that kind of issues, there are none. Okay. All right. Let's see what else we can talk about here. So I go back to the presentation, where we have a comparison between what the differences between the different cameras we have here. So when should you choose an Altum-PT camera, and when would you prefer a RedEdge-P camera, right? The biggest difference here is the thermal sensor for the Altum-PT. Of course, you can have more resolution, but the trade-off here, as I explained earlier, it's a lot of information that needs to go to this little compact flash card, right? And you can get up to 2 images per second, right? But you need to get into the settings, and I would recommend 1.5 images per second, not much more than that, right? So if you're flying with a fixed wing drone, you need to fly high enough. High enough means 120 meters should be okay, not much lower than that. Else the overlap is not good enough. And as I explained earlier, we need very good overlap to have a consistent multispectral map. Why would you need the Altum-PT? I got one here. I'm very happy with it. It's big. It's quite a big boy. Actually, it's also a little bit heavy. I did some flights with it this week with a Matrix 300 over a natural area, and the quality of the imagery is awesome. Also, the brightness of the image, it's a lot different than just a normal RGB camera, right? We can get into discussion on what the real differences are here. Anyway, okay, I got a new question here. It's about wildfire detection and post-disaster monitoring. So for the missions, we have identified potential utility of the integration of RedEdge-P. Is there a better option, more suitable? All right, I think that's also an interesting question here, especially that's where we as a company see a lot of growth. It's a bit sad because we see growth in natural disasters, and because natural disasters are occurring more and more. So what we recommend here, so for wildfire as such, I don't think that our cameras are the right solution here, because we don't transmit the imagery in real time. We don't have video on this camera. It only can take pictures, and when you're done flying, you can make a map, right? You can make a map right away and send the images right away, but that's an integration we don't offer. Our cameras have the ability for a drone manufacturer to add that information. So for example, DLS in France, they made this integration with our cameras that while you are flying, it makes the map in real time, like DJI does, right? But that's not something we can impose. That's something the drone manufacturers should integrate our camera into at a certain level, right? So I don't know if this is the right option for wildfire detection, where you just want to have coordinates of a particular fire. If you have the ability to have the good integration and make the map in real time, it may be of use. Then post-disaster monitoring. Here, what you, if it is for burned area mapping or vegetation recovery mapping, I think any of our cameras will do, because and a RedEdge-P is quite a good option. Due to the detail and the bands, it should be good enough for the fire post-disaster monitoring. Also, for fire prevention, we have seen a lot of people using our cameras for it, and they are using also the RedEdge-P, but certainly also the Altum-PT because of its thermal channel, right? And that with the combining the multispectral imagery and the thermal imagery, what you can get is the water content of a plant, right? And the temperature is determined you know, not just by the water content of a plant. You also need to look at how much bare soil we have around, what's the size of the plant. So that kind of information comes from the NDVI. High NDVI, big plant, and if that big plant also has high temperature, it's a big plant with a water content problem and a high fire risk. Okay, the other way around, if it is a small plant, but it has a low temperature, it can be okay, right? So combination of thermal and multispectral images gives you information on the fire risk, right? The fire propagation risk we might be talking about here, right? But again, this is not in real time. You need to make the map and analyze the data. But probably it's the same time as you can have from the satellites. There are many satellites around, but they are not flying constantly and not at the same resolution either. But it's a complementary tool, that's for sure. So yeah, very interesting, the topic of wildfires, of course. Okay, let's have a look here at the products you can get out of the camera. If they ask me, Eric, what really different projects you can get out of a RedEdge-P, I can tell you, because you can have an endless list of indices from the images, but many of them are correlated between them. So what I would mostly tell you can get like 4 products: the RGB image, which is good for the visual interpretation; the NDVI, which talks about the size of the plant on the amount of leaves we are talking about here; the NDRE and everything that's related to NDRE, which is the chlorophyll content of a plant. So that will be 3, and the 4th is the DSM. Then we can get the difference between the height of the plant, right, and the soil. So these are the 4 products, and if you have the Altum-PT, you can add a 5th non-correlated product, which is the thermal image. In case you have the dual camera, you can add a lot more information, because then what you don't do is not make as much indices, but what you make is spectral profiles of plants, and it's a whole other kind of science. So more and more remote sensing professionals that used to work with hyperspectral images and satellite images are now applying it on the scale we're working up here. So that's as I can compare to what we did like 8 years ago to introduce NDVI and NDRE to the community of drone mapping professionals, right? And explain what it is and how you can help a farmer with these information layers. Right now, our job, as we are adding more and more spectral information, our job is to start teaching about remote sensing and how to analyze information that we cannot visualize in one band, because we are talking here about 10 information bands, but we can only visualize 1, or combine it into one index like an NDVI or an NDRE and watch them side by side. So we need to start looking in the 3rd dimension of this of all these information layers. So you will hear from us more and more talking about spectral profiles related to different biophysical parameters as diseases and species identifications, and which remote sensing tools are most suitable for the analysis of that kind of data. All right, also a question we get many times. Right now, about probably half of the cameras we sell go on DJI drones, right? We'll see how that goes, especially in the US. More and more users from academia, important research institutes, government bodies, they are asking us, hey, Eric, which drone would you recommend us to fly with? Because we cannot work with DJI anymore. So there are a couple of other companies that some have a better, some have a not so good integration, but they have the ability to carry our cameras around, right? Except from DJI. So first of all, there's Wingtra. They only have the integration for the RedEdge-P, so not for the Joule or the Altum-PT. The good thing is they have end-to-end solution, so you can buy, because that's also many times customers come to us, okay, Eric, we need something that works, just one button, it should work. Yeah, I can say, okay, but we just make the cameras. We don't make the drone and we don't make software, right? So it is mostly the drone company that enables the 100% integration of the software with the full potential of the payload. So Wingtra is doing that right now. They have a very, very good integration with our camera, with their autopilot system, and their own post-processing software can seamlessly process multispectral maps. The only thing is Wingtra does not have a DLS on the drone, right? So maybe we can talk about that as well, about the calibration. We have the DLS on one side, we have the calibration panel on the other side. When should I use either of these? And how necessary is it to use these, right? So what I would say is your best bet for quality is use the calibration panel. Second thing that needs to be taken into account is when do you fly, right? Because you can have actually the panel should come on the second place on the quality of the data. The first parameter that you need to check is how is the day, right? It needs to be, for best results, clear sky, or even better, 100% cloudy sky. So there are also not any shadows. Then use the calibration panel under these circumstances. That's the best quality data you can get. If you can't control the weather or wait 1 hour more or less, and it's just a little cloudy as most skies, and actually today in Buenos Aires it's like this, then the DLS2 can enhance the quality of your data, especially if it's a long flight. The DLS2 actually delivers some good information. So if you're going for a Wingtra, it's only with the panel, and as long as you take control over when do you fly, it should be more than perfect. Another company I would like to introduce here is Inspired Flight. That's currently an American multi-rotor company that can carry our cameras and have a good integration, especially for the Altum-PT with their autopilot system. So that's definitely one I would recommend you to have a look at. Fixar and Delta Quad, there are VTOLs like Wingtra. Their integration is maybe not as good as the Wingtra, but you have the versatility to add dual camera and Altum-PT, not just RedEdge-P, right? Then AceCore from the Netherlands. You can put any drone, any camera on their drone system. The Neo is a very good platform. I like it a lot, and their integration with our camera is more than okay. All right. Are there any questions about applications? We talked about wildfire applications. We talk about biodiversity. I see that we don't have any questions yet about agriculture, right? Maybe it's because we talked already about that a lot. So, okay, question. Do you have any mounts for other drones like Inspired Flight? Good question, especially for our US public that don't have really access anymore to the most used DJI drones. Right now, we only sell mounts for DJI drones, either the quick mount, Skyport, that's what we sell for DJI, and we don't sell any mounts for any other drones yet, right? Because we don't sell the mounts for Wingtra, you need to get it from Wingtra, same for other drone providers. But we are going in the very near future offer a solution for American drones. It's called Dovetail, and that's not only Inspired Flight works with that mount, but also other drone manufacturers. So we definitely are looking into it, and we are going to offer it as we are working together with these companies to that. All right. What's the resolution of the thermal camera we are working with in the Altum-PT? Okay, let me go back here to the specifications. Okay, so for the thermal, we have 16 centimeters at 60 meter high. So that is the boson 320 lines, right? So this is actually the only way you can make maps with such a low thermal resolution, because if you only fly with this thermal camera with 320 lines, you cannot make a map because the resolution is too low. But because it is synchronous, it works synchronously with the multispectral images, and the tie points are projected to the thermal images, and we can make a map as well. Are we getting questions for having high resolution for the thermal camera up to 640? Yes. Are we bring out a new camera with that high resolution? Not for now, right? This is what we have right now. Also, thermal is a bit diffuse, right? Because it's not an image, it's not a map actually, or a pixel. It's a passive sensor. So we don't need reflection of the sun. We need to have objects that emit temperature, right, at a certain wavelength. So it's a little bit different how it works, and that's why we have always a lower resolution for thermal images. And even if you have a higher resolution, it doesn't make always too much sense. All right, the Wintra 1 Gen 2 has a DLS. Okay, thank you for the information. That's good to know. I wasn't aware of it, so good. All right. All right, thank you for information for Wintra. That's good to know. Comparison here. All right. Let's talk a little bit about, these are all about the applications here, like plant counting, some examples on how to visualize the data. Okay, another question here. Do our cameras work with Freefly Systems, right? Which is another quite well-known drone manufacturer in the US. Just as an Inspired Flight, we are also really looking into it. The good thing is they have enabled us to work with their mounts, which is the Dovetail, right? And we are shortly going to offer this option as an integration, not only for Freefly and Inspired Flight, but hopefully for many more drone companies that will adopt this kind of adapter, right? For us, it's a little bit hard to have a custom solution for each drone, right? The drones are, we have already so many different drones. It was easy when DJI was around and have like 90% of the market for professional mapping. So that was easy for us, but now we see more and more companies getting into the market and offering solutions with our cameras. So we need to see how we are going to do this to keep our products as generic as possible, but also as adaptable as possible. So that's the current challenge we have. I have a question here about where the cameras are made. The cameras are 100% made in the US. So it's 100% in the, maybe it's not really a question in other countries, but in the US it is actually a requirement, and we get a lot that question: where does your camera come from? Of course, it doesn't have any communication devices in the camera, but it does have some parts from other parts in the world, but no critical items come from China, and the assembling is made in the US, in Kansas. And I can't tell you what the percentage of local parts is, but it's really high. So that's what I said with what happened the last couple of months with the tariffs and price changes of import and export. It doesn't affect us too much because we source most things nationally. Okay, so what's the flight planning software used for these sensors? Well, okay, for those who follow us already for many years, know we used to have our own flight app, Atlas Flight. It's discontinued now. It's a pity. It was interesting, but it only worked for DJI drones, right? So we don't have actually our own planning software. But if you go into the camera, into the configuration, you can do a pre-flight check and a post-flight check, because the camera has its own GPS, right? And it doesn't need too much integration with the drone in order to make a map, right? You can set, the trigger options are the following. You can have an external trigger. You can trigger by overlap. So it flies independent the speed on the altitude where you're flying. Say, okay, I want to have 70% overlap, and always starting from a certain altitude. There is we have on YouTube, there is a link that explains how the configuration of our camera works. You get into the camera, right? And you can simulate the map you're going to fly. After you're done flying, you can simulate the overlap, so you can see if there are any gaps or images that have not been taken, or the flight plan that wasn't good enough. So there, we don't have our own app. How do most people work, right? If you're working with DJI or any other flight app, you just put the camera parameters in the flight app. Most of them have already by default a RedEdge somewhere. Else you need to edit yourself, right? If you want to have the data for the input, you can find on the web, just or ask ChatGPT, give me the camera parameters for mission planner of the RedEdge-P, and you can get how many lines the sensor is. You can get the angle of the lens. And that's the information you need for your flight planning. You can also go to our website. If you go below, just on the lowest part, you have MicaSense Flight Calculator. Very interesting. Here you can say, okay, I have 100 hectares. I want to fly at 100 meters altitude, having a fixed wing, and I want to fly at 50 kilometers per hour or meters per second of miles per minute, whatever units you're using. And it gives you how many pictures you will take, how many gigabytes of information you will have, because on these cards only 128 gigabytes. So that's the limit of what you can do. Usually it's enough, right? You can do like 10 flights. Usually for one flight, you can get between 5 and 15 gigabytes of information and imagery. So that's the way that most people plan. This flight calculator, you have that also in the on the camera itself, right? You can connect to the camera over Wi-Fi. There's like a Wi-Fi dongle on the camera. So you can connect with your phone on the camera and look at the settings, do the pre-flight check, simulate your flight, and after the flight, you can get also into the configurations and have a look at it. You can also have some live view, especially interesting if you want to have a picture of your panel and you want to see if you can shoot it right. Usually it is. If you just hold it above the panel, it's always right. All right. That's about the flight planning. The purchase. What's the best way to get a camera of ours, right? Depends where you are. We have a reseller in most countries. I cannot tell you in every country, but in most important markets, especially if you are anywhere on the globe, you must understand that like 80% of our cameras go outside the US. So they're very popular in China, they're very popular in Europe, especially in Germany, Spain, Italy, and in South America. It's a little bit expensive, it's harder to compete, but the research institutes and international ag companies are making good use of it, especially in Brazil, Chile, Colombia, and we see more and more interest in these countries, because land management is also so important in these countries, and the usage of drones, of course. So you can also buy on our web store, especially if you want to have some accessories. And if you don't have a local reseller, you can come directly to us and get a quote. You can write me an email, and I'll get you a quote. We ship everywhere with FedEx. So that's the best way to get your purchase order done with us. Next question about the DLS. Is it possible to work without the DLS? It is. You can work without the DLS, right? The thing is, you need to have the DLS. Is not just a light incident sensor, it's also the GPS of the camera. So it's mandatory to have GPS data for each image that you take. So if you take out the DLS, you need to have another source for the geotagging of the images. So you need a very good integration with your drone, right? So the camera, it has here different ports, as you can see, right? And one is the Ethernet port. And with over the Ethernet port, you can insert GPS data, as for example, the RTK from DJI that goes over the Sky port, or Wingtra, for example, that also goes directly to this Ethernet port to get you the RTK data if you don't use the DLS tool, right? So yes, you can. Then I got a question here from Mauricio. What about the RTK GNSS receiver on Ag Eagle sensors to avoid targets on the ground? Sorry, I don't understand that question. First, because we don't have an RTK receiver, and secondly, avoid targets on the ground. Okay, I don't get this question. All right. What else here? Oh yeah, what I was talking about, the more bands we have here. So that makes it possible to do species identification, right? To identify a species, especially if it's in this case weeds, mustard weed, or if you're doing biological mapping and want to differentiate between species, there are different dimensions, right? One is the spectral information we talk about, but also the evolution of the vegetation over the time, right? Okay, so to have a time series and do some time analysis, it is also, you know, another dimension, which is like the temporal resolution, if you want to call it, where you can find different phenomena. And this is so important, why we pay so much attention to the calibration panel when you fly, the DLS, everything what you can do to have good reflectance data is needed if you are going to make a time series. If you want to compare one image to the other, the values of the reflectance need to be comparable. So no noise whatsoever, because then you are measuring noise differences and not growth differences of plants, right? So that's why MicaSense cameras are so relevant, because of this, all these tools we have to optimize the quality of the reflectance values of the bands in order to do these time series analysis, which are more and more used, especially now because we have drones in a box. The expensive part of making maps is somebody needs to go to a place and fly, right? So once now we have the drones in a box, and we have already some boxes around that have our sensors in it, they fly every couple of days or every week, and the images they need to match, right? And then they're going to make graphs on the growth evolution of certain plants. Really interesting. We will see more and more of that in the future. Okay, Peter, I have a requirement of a RedEdge sensor for water quality analysis. What are the parameters I can detect in water? Is there any lightning constraints? Okay, interesting your questions. And I actually would like to add one more thing to it. Because number one, how can we make maps over water, right? Because currently, when we need to make a map, we do it with photogrammetry, we need overlap between the pictures, and these points between two different pictures are matched together, right? And then we can make this mosaic. But if you fly over water, there are no points that match because the waves are moving all the time. The angle of the sun is different between every picture. So it's very, very hard to make a map over a water body. What you can do is make maps of coastal areas or just look at the individual images. I had the other day talked with some people from California that are making maps of an area where sharks and whales meet. Very interesting. And they don't make the map. They just have one geolocation located image next to the other one, and there might be a little shift between the two, of course. And the other is have better and more information about the position of the drone. If we really know the location of the drone, the distance to the soil, and the angle of the camera, we can actually project the entire image on a map. So each image is a map. That's probably the way the technology will go. I think it's very interesting because that will also mean that you don't need that much overlay. Okay, that being said, what else can you do for water quality? I'd say with the NDVI, you can see algae and have the amount because of algae because of the NDVI. It works also over water bodies. Then I would say, okay, why don't you use the blue camera because it has the coastal blue band where you can see how clear water is, and then also if it is crystal clear images, for example, like a coastal area of the Mediterranean coast, you can actually map the bottom as well, or even coral reefs are also mapped just by what you can see through the water, right? But if the water is like not really crystal clear, it's very hard to make a map to start with. Okay. Okay, thanks Mauricio for the clarification of your question. If we can replace the current GPS, the DLS plus GPS we have, and replace it by the RTK of the drone, yes. So that's what I explained earlier. There is many drone manufacturers. You can either use it with the Skyport. If you work with a DJI drone, it enables directly the RTK corrected data will be written into our EXIF files of the cameras. And if you want to make a solution for yourself, you can also do so. And I refer to the MicaSense user manual, where it is explained exactly which pin outputs are needed and how the configurations must be set in order to receive the RTK data into the camera and write these to the EXIF file of each of the images. So yes, you can. This is the way how you want to do it. You can send me an email and I will send you the link to the document where it explains on how to implement this, especially if you don't want to work with a DJI drone. If it comes with a DJI drone, it is already implemented if you have come with a Skyport. Okay, trainings. Are there trainings you can get on how to work with our cameras? There are different kinds of trainings, right? Learn how to work with our cameras. I think that's easy. It's part of the success of MicaSense cameras because they are so easy to operate, right? Compared to other kinds of cameras or more complicated cameras, all for remote sensing applications, right? If you compare it to a hyperspectral camera, it's easy. If you compare it to other multispectral camera, it's also easy. Both the acquisition of the data, the operation of the camera, and offload of the data. Where most people need training is on the analysis part of it, right? Because the intermediate thing is how to make a map, which you can do with Pix4D Fields or Agisoft or any other software that's around, and just make a 2D map. That's also almost one push on a button to get you a map. The interesting part is how to analyze that data. It's not just by making an NDVI map. What do you do with that information? How does it relate to real life biophysical parameters in an agricultural field, depending on the location on the world map, depends on the growth stage of your crop. What do you want to do with the data? All that kind of information, that's where really the learning process starts, which you can get over time using the camera, verifying with ground truth what's really happening on a certain kind of field. Not just talking about agriculture, it's also about species mapping, for example, going to the field, relate, make analysis. So this is like remote sensing work, right? So probably if you want to take the best out of our sensors, I can recommend you online courses using QGIS, which is a GIS platform where you can analyze maps, mostly the vector part and not as much the raster part. Images is like pixels. So the first place will be, okay, have your image, convert all these pixels to vectors, and then make your analysis. So that would be like a QGIS training you can get. If you really want to get into spectral analysis, I would recommend you to go directly to a remote sensing training, where they will talk to you about Sentinel and Landsat and all the other satellites that are flying around, and apply it on what you can acquire with this camera. So there is a lot to learn. There are entire careers on remote sensing that take years. I think if you dedicate yourself 2 weeks, 100% on remote sensing and GIS, I think you'll get quite a long, far with the interpretation of the data. All right, lead times. All right. Don't really know if I need to say this, but our lead times, mea culpa, were horrible, right? Right now, our lead times are 3 days. So if you want to have your product in the next 14 days, you are okay, you will get it. All right, so I think we are taking this, I've been taking quite some questions here, and I don't know if there are any more questions. We are already over the hour with this Q&A. So thanks a lot for everybody. I don't know if anybody has a last question that that I can answer, and if not, I really thank you guys, you know, and for all the very interesting questions, and please don't doubt about sending me your inquiries, and I will be happy to help you myself or either one of my colleagues, Sam Yates, who is working from Tokyo in Japan, or Brian, who's here to answer your questions in the US. Right. Okay, I see there are no more questions, so thank you everybody for attending, and talk to you soon. Goodbye.